In this video, we're going to go over some examples associated with mathematical induction. So let's say if we have this statement, 3 plus 7 plus 11 plus 4n minus 1. Let's say that's equal to n times 2n plus 1. Now let's test it out with some numbers. Let's see if it's true for the first term. So the first term in this sequence is 3. And n is 1, which represents the sum of terms on the left. So we only have one term, so the sum has to be 3. So if we replace n with 1, this is going to be 1 times 2 times 1 plus 1. 2 times 1 is 2, and 2 plus 1 is 3. 1 times 3 is also 3. So it's true for n equals 1. Now what about n equals 2? Will it be true for that as well? So on the left, we have the sum of the first two terms. That's 3 plus 7. On the right, we're going to plug in 2 into that expression. So it's going to be 2 times 2 plus 1. Now 3 plus 7 is 10. 2 times 2 is 4 plus 1, that's 5. And 2 times 5 is 10. So it's true for n equals 2. Now, is it true for n equals 3? So this time we need to add the first three terms. That's going to be 3 plus 7 plus 11. And on the right side, let's replace n with 3. So it's going to be 3 times 2 times 3 plus 1. Now 3 plus 7 is 10. 2 times 3 is 6 plus 1, that's 7. 10 plus 11 is 21. 3 times 7 is 21. So it's true for n equals 3. Now this indicates that this expression might be true for all terms, but it's not a guarantee. It could be true for the first 3 terms, but for the 15th term it might be false. So we need to come up with a way to make sure that it's true for any term. So let's say if it's not true for the 28th term. Instead of testing it 28 times, we need to come up with a general way to see if there's going to be some value that is not true. So what we're going to do is use a letter k. So we're going to assume that it's true when n is equal to k. So let's replace n with k. So it's going to be 3 plus 7 plus 11 plus 4k minus 1. And so we're going to assume that this is true. Our task is to prove that the next term is going to be true. And that is when n is equal to k plus 1. So on the left, we're still going to have 3 plus 7 plus 11 plus 4k minus 1. But then we're going to add the next term. And so the next term, we just got to replace k with k plus 1. So it's going to be 4 times k plus 1 minus 1. That's going to be the next term. Now on the right, this entire sum should equal this expression if we replace k with k plus 1. So everywhere you see a k, replace it with k plus 1. So it's going to be 2 times k plus 1, and then plus 1. I'm running out of space there. Now we need to prove that the left side and the right side are equivalent to each other. Now notice that this expression is equal to k times 2k plus 1. So therefore, this portion of the equation has to equal to k times 2k plus 1. So we can replace it with k 2k plus 1. So how can we prove that these two sides of the equation are equivalent to each other? Feel free to pause the video and try it. For this example, the best thing to do is to combine like terms, distribute, and FOIL. So let's focus on this expression. Let's distribute k to 2k plus 1. So it's going to be 2k squared plus k. Now let's distribute the 4. So we're going to have 4k plus 4 minus 1. On the right side, we're going to have k plus 1, and let's distribute the 2. So it's going to be 2k plus 2 plus 1. Now we can add 4 and negative 1. 4 minus 1 is 3. And here we can add 2 plus 1. 2 plus 1 is 3. On the left, let's combine like terms. So we have 2k squared, k plus 4k, that's 5k. And on the right, we need to FOIL. So we're going to have k times 2k, that's 2k squared, and then k times 3, which is 3k. And next, 1 times 2k. And finally, 1 times 3, which is 3. On the right side, let's combine like terms. 3k plus 2k. So on the left, we're going to have 2k squared plus 5k plus 3. And on the right, we're going to have the same thing. 3k plus 2k is 5k. So the left side is equivalent to the right side. So that's how we can prove that the original statement is true for any term, or for any value of n. And so that's the basic idea behind a mathematical induction. Now let's try another example.